OSI, Open System Interconnect. We learned that there are 7 layers. The top one, layer 7, is application. What is this layer explains us? It explains the applications that are created for us to generate a traffic that can interact with the network. See, I'm having a paint. I'm having this paint application. Can I use this paint to write a mail? Tell me. Can I use paint to write a mail? Can I write an email through paint? Yes or no? Answer no. Yeah. Can I use a paint to write a mail? Answer is no. You need a browser like Chrome or Microsoft Edge. Using that browser, using that application, you go to that domain like Gmail or Yahoo, and then you write a mail by clicking the compose button. So you need an application that will talk to the internet. You cannot use any application. You need specifically a browser. Without browser, you cannot write a mail. Why you cannot write? Because browser only have got the programs, the set of instructions that will take your message as a mail and deliver to the receiver's mail address. That program, that instruction is not available in Paint or in a Word document. Those instructions, those commands are not available. So in order to write a mail, you need a browser. Likewise, in order to watch a video, you need YouTube. YouTube is in browser. In order to upload a file, download a file, means to transfer file, you need browser. In order to telnet to a device, you need PuTTY. PuTTY is a kind of tool through which we telnet. So for every specific services, you have different applications. Every application will have a dedicated protocol. For example, to see a web page, HTML, that uses HTTP protocol. For telnet is a protocol. For file transfer, FTP is the protocol. For sending mail and receiving mail, POP3 and SMTP, Simple Mail Transfer Protocol, SMTP. So we have different protocol for different work, different services in the internet needs different protocol. Different application have got different protocol. So describing about that application, describing about the protocol, what protocol to use, is specified in this layer called application layer. It is mentioned in this layer. In order to transfer a file, application layer says you should use FTP tool. You cannot use a browser and do telnet. You need a FTP supporting tool. So the browser has got all those upload, download, FTP package. Browser has got a lot of packages for sending mail, for receiving mail, for watching video, for uploading documents, for uploading videos, downloading videos. The browser has got a lot of small sub applications. Browser itself is a very big application. So describing about those network application, describing about the network application is what you will see in application layer. I'll ask you a question, you should answer. If I want to transport 7,000 liters of honey, you know honey? Mita, honey. If I want to transport 7,000 liters of honey, what I need, do I need a jeep or do I need a lorry with a tank? Of course your answer will be lorry with the tank. Jeep is not the right vehicle. It's 7,000 liters, so you need a tank or lorry. Likewise, if you are doing file transfer, HTML is not the protocol. You need FTP. So those things are described in this layer called application layer. The layer which defines which application to use for what services. Secondly, layer 6. This has got presentation layer. Presentation layer. Presentation layer present the data to the network, the data that you are sending, no? It presents to the network with the correct protocol that application has decided to use. So the job of presentation layer is to present it, give the network in such a way that network can understand. That is presentation layer. The layer that describes the way that the packet should be given to the network so that it will go without any problem till it reaches the destination. And destination, when they receive the packet, they will know how to handle the packet. See, when you are sending a PDF file, can I open that with the MS Word application? No. I have to open with Adobe Reader. Likewise, in networking, the sender and receiver knows how to handle the packet. It is because it has been presented very well, so the destination will know with what he has to open the packet. If no presentation layer, then the receiver will not know how to handle it. You might have sent a Word file. Now receiver do not know whether to open it with Word or Adobe Reader or with some image reader. Presentation layer is very important. If you go to a restaurant and order for food, one full chicken biryani, one full veg biryani, one mushroom fry, one chicken tikka. You have ordered 4 things. Now they put it in a bag and they give you. They put it in a box, in different box, and they put it in a bag and give you. And when you come home, your friend is a non-vegetarian. You should give him chicken. How do you know which box has got chicken? Because there is a sticker on the top. Chicken biryani. In the other box there is a sticker. Veg biryani. So that is presented very well by the restaurant guy. That is why without confusion you open the correct box. If the sticker is not put there, sometime you will give your friend a veg biryani, but he don't like veg biryani. He like chicken biryani. You see, the presentation is done in the restaurant. That's why you don't have confusion. You give veg biryani to vegetarian, non-veg biryani to non-vegetarian. Same way, the sending computer should put that sticker. Arey Baba, this is veg biryani hai. Only then the receiver will open that with the correct application. Presentation layer is taking care of presenting the data to the network so that network will tell the destination device how to handle this packet. If you send a video, the receiver will know it is a video. I need to open with a VLC player. It won't try to open with the PDF reader. See, sometimes you ask some question after I finish the class. No. Then and there you ask the class. Usually when I am finishing the class, I will be very tired. That's why I am finishing the class. When you ask such big questions, I get really disturbed. If you have questions, right in the middle itself, you stop me and ask me. It's good for you and for me. Now, do you have any question on application layer and presentation layer? No.
Sir, can you explain again for presentation layer?
Presentation layer. Presentation layer helps to present to the network. See, we human beings understand Word file, PDF file, video file. But how network will understand? Sometime I will be sending Word file, sometime I will be sending PDF file. So this presentation layer is the one which is telling the network in a language that network will understand, saying this is a Word file. Why should I make a network understand it is a Word file? Because when it sends to the destination should know how to handle it. So network should tell the destination this is a Word file. So if network should say it's a Word file, then I should tell the network this is a Word file. So presentation layer present, see that's the name they have given, presenting. Presenting to the network what sort of data I am sending, so that the receiver will know how to handle it. Do you still have question, Kiran?
No, sir.
Good. Let's go to the next one. Next is session layer. Session. Session layer, as the word says, session. What is session? Time. See, you are asking a friend, hey, what time you are coming? He says, I'll come in half an hour from now. Then you will wait for half an hour. You will not call him, disturb him. Because he said half an hour, you will wait for half an hour. After half an hour, what do you do? Sometimes you will leave the place, but sometimes you will call again. Hey, what is that, man? You said half an hour, you didn't come. Likewise, in networking, there is a sender, there is a receiver, there is a request, there is a reply. When I send a request from one computer to another computer, if reply is not coming, someone should say, we have waited, the reply has not come. We have waited. Say for example, you are pinging. If ping reply is not coming within 2 seconds, then someone should tell the operating system, see, it's supposed to come within 2 seconds, it didn't come. That someone is what called a session layer. The timekeeper. If it is not coming on time, it will intimate the operating system so that operating system can take some decision. Sometimes it may discard, sometimes it may re-request, resend. So session layer takes care of sessions, the timings. I'll give you another example. Nowadays we all have fast internet. YouTube is always available. But few years back, people were using torrents to download big files like movies and so on. Torrents. By using torrents, let's say you are downloading a big movie. That movie can run for like 3 hours, 4 hours. That movie is a Blu-ray movie, which is of 2 GB size. You know, the Blu-ray is high quality video. I don't know nowadays Blu-ray, I don't think people will create Blu-ray videos. Nowadays we have HD videos, high definition videos. But the Blu-ray files are too big. High definition, Blu-ray. This is all quality of video. So let's say you are going to download a 2 GB RAM, 2 GB size data. You started the download using torrents. Before you start, it will show you estimated time. Estimated time. It will show like depending on your network speed. Let's say it shows 1 hour. It says 1 hour, we'll finish downloading. How it knows it will take 1 hour? Because session layer can judge it. Session layer is sending a packet and a response is coming. Session layer is seeing how quickly the response comes, how much time it takes for the response. If it is too quick, then download time will be less. If it is long time, then it will say 1 hour it will take, 2 hours it will take. So session layer is taking care of all those time related to a packet, to a data transfer. Session layer is very important. Without time, you don't have networking. I'm repeating again. If no time, no networking. Time is very important. You see, in your computer you have time. In your cell phone you have time. If you ask what is the capacity of hard disk, they will say 1 TB. And how fast is the hard disk? Then they will say in hertz. What is hertz? Time. If you ask processor, then they will say in speed, like 5 megahertz. Hertz is nothing but time. Per second, this is the speed. Per second is 1 gig speed. 1 gig per second. You see, time is what very important for networking. Not only for networking, computing. IT depends on time. So this time that you have in your cell phone and in your laptop, it is not only to see clock, the time, the device itself needs time to operate. You change your clock to 2001. Today is 2022. You change your clock to 2001 and try to open any website. You will know what I am saying. No website will open for you. If some website opens, it will open like half, not fully opening. Only the static pages will open. You cannot do any bank transaction. If you change the timer in your laptop to very old time, your laptop cannot work. Your browser will not open YouTube. Time is important. Based on time, certificates are generated. Without certificate, browser cannot open a web page. So everything is time based. That's why I said no timing, no computing, no networking. Bandwidth is also measured using time, no? 100 megabits per second. MB per second. For data communication, the session maintenance, the time maintenance is very important. Otherwise, what will happen if there is no time? You send a request, someone is not responding at all, then your computer will be keep on waiting for the response. It won't do any other job. It will wait for the response. Only when response comes, it will do another job. That will become a problem. If response is not coming, it has to take some action. Okay, start another process. Leave this one. Right? You can see that in some banks. They will simply say server not working. Okay, so what? I have traveled 10 kilometers from village. You cannot say server is not working. I cannot go back. Finish my work. They will not do. Sir, only when server comes, we can do anything. I don't know. As if they are coming from moon, they will talk. 15 years back, no computer in the banks. How it was working? See, they don't want to work. Lazy fellows. That server is not working. So only when server works, they will do the next work. Otherwise, they will not do. They will simply sit and talk. All the customers should be in problem. If you don't have session layer, that is what will happen. Because you have session layer, it waits. Okay, I waited this much time, so I should not wait anymore. I should do the next work. It will go to the next work. Computer will go to the next work. If no timer, then you will not know how long the wait has happened, and you will not be able to take a decision. Timing is very important, right? Session layer takes care of the session. If a packet needs to go, it has to get the reply within this time. If it is not coming, then we have to take some action. Like you should tell request timed out, or we need to resend the packet. Something like that need to be taken. For that, session layer is very important. See, when you are talking, when I am talking, you are very silent for a long time. If someone is silent when you talk over the phone, what you will do? You will stop talking and you will say, hello, do you hear me? Are you there? You will ask, right? Why? That is session layer. You want to know that whatever you are speaking is being heard. If long time silent, only then you stop your conversation and you say, hello, are you there? Can you hear me? You are there? You ask it. You ask your friend. If he says yes, then only you continue your conversation. So you have in your mind a session layer. When you say hello, if someone is not saying hello, what do you do? You say hello again. Did you call him to say hello? No way. You called him to say, my friend, tomorrow I am not going to be in town, I am going London. That's what you want to tell him. But when you called him, he says, he's not saying anything. You say hello, he picked the call. But you say hello, he is not saying hello. If he is not saying hello immediately, then you will say hello again. Till he say hello, you will not tell that you are going to London tomorrow. You keep repeating that hello, 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 hello. First you want to establish a connection. Only after establishing connection, only when he says hello back, then you have a confidence that yes, he is listening to what I am saying. For which session layer is important. You wait for a period of time and say once again hello. No hello is coming. Again you say hello. Alright? So there is a time that you wait. You expect hello within the time. If the hello is not coming from the friend within the time, you keep saying hello. To make the decision, the session layer was important for you. Similarly, in a computer, if you see, in a computer or in a router, in all these devices, there are multiple services running. All the service wants to use the processor and the network. So there is need for a time frame to say, okay, this time you go, and reply need to come to you within this second, and then after that you go. After that you go. You need to set a time. Only one processor, right? All cannot use at the same time. So session layer is very important for any device, whether it is a router or a switch or a computer or a server, cell phone, everything depends on session layer. After session layer provides the time frame for your data, comes the transport layer. As the word says, transport layer. The transport layer takes care of transportation. That is why they named it as transportation. See, none of these words are just like that spoken. Every name describes what the layer means. Application layer talks about the network related application like browser, like POTI, like FTP tools, Wireshark and so on. Presentation layer talks about the protocol that needs to be used to present it to the network. Session layer talks about session, timing, when to send the packet out, within what time the packet should get the response. Transport layer talks about the transportation, how the packet needs to be taken, transported. What should be the size of each packet? All those things are determined in the transport layer. See, if I want to send 2 GB of data, can I send all 2 GB just like that in one go? No. I will not have 2 GB wire. Let's say I got only 10 Mbps wire. 10 Mbps wire. But how much data I want to transfer? 2 GB. Transport layer, what it will do, it will break the 2 GB data into small pieces, so that the 10 meg cable can easily transport it. And then that small pieces can be reassembled on the receiving side using the sequence number that is provided from the sending side. So sender, what he does, he takes the big data which cannot be sent in one go, cut it into small segments and provides name, number. This is the first piece, this is the second piece, third piece. He numbers it so that on the receiving side it can be rearranged according to the number. Sending side, big data is chopped into small data. Receiving side, all the small data is collected, arranged in sequence and made it as one big data. So transportation is easier only when you do segments, small pieces, fragments. Transport layer takes care of that segmentation, piece. Yeah. So transportation is taken care by the transport layer. Not only that, this transportation layer also does two types of communication. One is connection oriented communication, the other one is connectionless. We call it as TCP UDP. But more about this I want to talk in the next class. I do not want to get into it. Now we are just talking about the OSI layers, what they are, what they mean and so on. So the job of transport layer is to transport the big data easily by segmenting it. The segment size is dependent on the bandwidth that is available in your media. If your cable has got only 10 meg, according to that, transport layer will take your big data and segment it. That's the responsibility of transport layer. See, every layer has got a separate job to do. They all have to do those jobs, only then the packet can go out in a network. OSI layer describes the job that need to be carried out in preparing a packet for sending to a destination, and when a packet is received from the destination, the same OSI layer decapsulate those encapsulation and provides you the data. So far what we have seen is our big data using an application we created, and it is presented in a particular time, and it is now transported. Now, transport to where? Transport to an address. So there is a layer 3 called network layer, which is going to explain the network where to send this packet. Network, to which network to send this packet. For example, if I want to send a letter to Kiran, if I just write to Kiran, is that enough? No. I need to say to Kiran, which state he belonged to. I have to say which state using a pin code. If I don't do that, what will happen? First of all, it won't be a valid packet. Post office will not accept it. Why? It is very difficult to find Kiran, because there are many Kirans in the world. Even in my same street there may be one Kiran. Which Kiran this letter belonged to? So I have to say the city name, the street name, the house name. That is what network layer. To which network this packet belonged to. After reaching the network, in that house, to whom should I give? Kiran. That is the MAC address. Data link layer. So network layer takes care of providing the network information of the source and destination of the packet. Source IP, destination IP. Network layer takes care of source and destination of the packet. Data link layer takes care of source and destination MAC address. Of the packet. See, every layer has got something very important for a packet to go successfully to the destination. If any one layer stops doing its job, then finish. The packet cannot be sent. If you don't have network information, it's not possible for you to send the packet. If you don't have a MAC address information, not possible. Session ID should be set. Protocol need to be presented. Right application need to be used. All these layers have got specific function. They all need to do their function. Only then the packet will be sent out. So at last what happens? This encapsulated packet, the data, is now sent over the physical medium. Maybe it may be a Wi-Fi adapter, or it can be a wired Ethernet adapter. It needs to be sent over some adapter, some physical medium. That's why it is called physical layer. Physical layer. See, don't say Wi-Fi is not a physical. Wi-Fi, it's a wireless signal. I also understand that English, Wi-Fi, wireless. But to do wireless, what do you need? You need a wireless adapter, no? That wireless adapter is a physical component, no? That physical component only takes your data and converts into radio waves. Correct? That radio waves, how you got? Can data link layer provide you the radio waves for Wi-Fi communication? No. You need a box, special hardware. That's called physical layer. It can be a wireless adapter, or it can be a NIC card through which you can send over the Ethernet wire. So, physical layer takes care of physical connectivity. Every layer has got its work. So, if you are sending through a physical layer, if it is a Ethernet wire, then as per the Ethernet standard it will send. If it is a wireless adapter, as per the wireless standard like IEEE 802.1BAGN standard, it will send. So wireless standard 802.11 A, B, G, N. These are all Wi-Fi standards. For a Ethernet wire, you have Ethernet standard. So those things, who takes care of it? Data link layer. See, if you don't install a driver, for your Wi-Fi adapter, what will happen, you know? Your Wi-Fi will not work. Why? The physical layer is not working. Someone should take the data link layer data and convert it into Ethernet standard or Wi-Fi standard. That conversion, the trans receiver, is only in the physical layer. So only when we install the driver properly, that conversion will happen according to the medium. If it is Wi-Fi medium, someone have to translate to radio waves. If it is Ethernet medium, the physical layer will translate to Ethernet standard. And then, so it is coming out, whether it is Wi-Fi or wired, it is coming out like bits and bytes. It is sent out. So on the sending side, it starts from application layer, goes till physical layer, and on the receiving computer, these both are communicating. On the receiving side, it will be in the opposite. Data comes in to the physical layer. Physical layer receives it like a radio signal or Ethernet signal, converts it into frame. Here it was frame. It converts it into frame, which is data link layer, and when the receiver MAC address is matching, it opens the next layer of the packet, which is network layer. It checks whether the packet's network and this computer's network is same. PSEKET, the data here we called as packets. If the destination IP address matches with the local computer, then it opens the transport layer and then it checks what to do with the packet. It rearranges the packet. Here we call it as segments. Our data in the transport layer is called as segments. And then all the segments are assembled, and the session, it checks whether it is received on the right time. It maintains the session for the reply, and by opening the presentation layer, the receiver knows what type of packet it is. By opening the presentation layer, the receiver knows that this is a Word file, because in the sending side it was presented as a Word file. So the receiving computer opens it with MS Word. It won't try any other application because it's a Word file. It will use text file, text pad, notepad, or a Word, MS Microsoft Word. So data is sent as a Word, received as a Word file. Communication is over. Successful communication. So for a successful communication without any confusion, this OSI preparation, 7-layer preparation, is very important for a packet to be sent and received successfully between source and destination. Please ask me a question if you have about this OSI. Question time.
So in receiving side, session layer is check at what time it's coming, right? So
Yeah, it makes a note at what time it is coming, so that if need to be replied, it will know within what time it has to reply. Kiran, you have any question?
Each layer has different protocols or same protocol?
Different protocol, different job to do. Every protocol has got different job to do. So different algorithm, you can say. You can call it as protocol, but we don't know about the protocols. We don't need to worry about the protocols because it is taken care by the operating system. The top 4 layer, you don't have anything to do. Automatically it will be taken care by the operating. That's the job of operating system. It can be Windows or Linux. They take care of those jobs. Even we don't decide whether to use TCP or UDP. Those things are also taken care by the operating system. Most of networking people's job, most of the job is here, in this 3 layer. So we'll talk about this IP address, MAC address, difference between TCP, UDP, port numbers. There are various port numbers, like for example Telnet 23, HTTP 80, HTTPS 443. Kiran, kindly mute your mic. And then SSH 22, FTP 2021. Both are FTP, Telnet, HTTP. Likewise, you have port numbers, 52, DNS. So these all work on transport layer. Who decides this port numbers? Which port to use? If I am telnetting, automatically port number 23 is used by the transport layer, automatically. Based on the application that you use on the application layer, the protocol will be determined. Another question? We'll be talking about TCP UDP difference in the next class. About the IP, we'll start after that. IP is a big chapter. We need to learn subnetting and so on. But before that, we'll finish TCP UDP differences. Any other question on what you learned today? Alright, if no questions, we will meet in the next